Hi, everyone. Welcome. I'm Angela Chen, co-founder at Esquilabs. Welcome to the second installment of the Esquilabs Demo Day for our Cohort 6 Data Science Fellows. Today's theme is the future of data in government and policy. And I hope that today's session will engage you in this topic in a new data-driven lens and perhaps provide a respite from some of the heavier news that we always see around this topic. I'm also really excited to engage our colleagues and friends, Felicity Tan from WeSolve and JC Peralta from our education team. We'll just introduce them in a second. Let me first give you a quick introduction of who we are for those who might not know Esquilabs, and let me also share with you how today's event is going to work. So Esquilabs is an online data upskilling school based in Manila, and our mission is to democratize the future of work through data skills and education. And today's event is a part of a series of demo days, which will showcase the work of our data science fellows who completed a 12-week part-time program to launch their careers in data science. And so the fellowship is not just about skills building, it's also about a community that's curious about how to use data to advance innovation and impact. Many of our fellows will go on to work in industry. And in fact, through new interview guarantee partnerships we've introduced this year, fellows can choose to have guaranteed interviews at innovative companies like Quadex, Home Credit, Kumu, and more. But before they arrive at that future, they're going back to one of the reasons why they wanted to learn data in the first place, which is to build a world that works. And so this demo day is inspired by cult classic Back to the Future, where we envision how data will become a big part of our future lives through innovations in the startup ecosystem, through better governance and policy, and contributions to COVID and climate change solutions, all through projects which provide a unique Philippines context. So to join our conversation today, we've invited Felicity Tan from WeSolve and JC Peralta, one of our data science instructors, to react to capstone projects that will be presented. So I won't read off their full bio because they're very accomplished people. But very quickly, Felicity is a connector, strategist, and overall, let's make this work leader. Felicity is now leading strategy and development at WeSolve, a first of its kind social purpose organization in the Philippines, specializing in supercharging cross-sector collaborations and incubating coalitions for systemic change. Previously, Felicity was a director for Asia at the Rockefeller Foundation and a journalist. And JC is a data scientist currently at Ayala Corporation Energy Philippines. He's also trained for 6 years as a climate researcher, specializing in regional monsoon dynamics and climate model evaluations. So I'm really curious about their reactions to these projects. And so let's stay tuned for the live Q&A. And if you're watching this on Facebook Live, you're invited to join us in engaging with the projects later through the comments. And also please stay tuned until the end of the event where you can vote for your favorite project and explore other opportunities we have in store for you. Now to kickstart our first presentation, I'd love to learn from the audience if you have registered yourself to vote in the next election. So data is about power, so are elections. Our first group explores the possibility of using data to promote competency-based voting over personality-based voting by creating a tool that summarizes candidates' platforms. Now let's welcome Roz, Hurley, Joseph, and Razel.
Good evening, everyone. I'm Joseph. Our capstone project is entitled Make Sense, Campaigning for a Data-Driven Election. Together with me are Rods, Hurley, and Razel. Youth's voting power will shape the election for years to come, starting 2022. According to COMELEC, there is an estimated 62 to 63 million voters in 2022. There are 4 million potential registrants who turned 18 this year that could register to vote. Last 2019 midterm elections, as high as 31% of the voters are from the ages 18 to 29, the Gen Zs and the Millennials. According to the 2019 Functional Literacy, Education, and Mass Media Survey by the Philippine Statistics Authority, the youth has the highest functional literacy rate at the average of 95.5% compared to the 2013 study of an average functional literacy rate of 94.4% of that age group. The future looks bright for our youth. If we look back, however, at how we vote, Philippines is still dominated by personality-based politics instead of issue-oriented governments. This gives us a question. How do we change this personality-based voting to goal-based voting? To try and aid this transition, next slide, we need the most influential tool we have in our modern age, and that is none other than the social media platforms. The use of social media platforms is practically free and has the potential to reach a significant amount of potential voters and supporters. But how are the candidates are using these platforms? We use natural language processing techniques to uncover what are the candidates are saying, what are the sentiments that can be derived from their posts or tweets, what are their political stance, and what needs to be done. Next is Hurley to discuss the data science method.
Thank you, Joseph. So for our data science method, first, we start by understanding our problem of converting personality-based voting to a goal-based voting. We then proceed to understand our data, specifically candidate tweets, audience tweet, news articles, and candidate Wikipedia pages. After which, we prepare our data by removing hashtag mentions, punctuations, and the like. After preparing our data, we can now do analysis with it using natural language processing. Specifically, we're going to be using latent Dirichlet allocation and zero-shot learning to get relevant topics from our text data and to relate the audiences with their candidates. After doing such, we can then proceed to our model evaluation, which we can then repeat until our model is good enough for deployment. For our first question, who is saying what? This is going to be answered by Joseph.
Okay, to answer our first question, we analyzed the tweets of the 2019 senatorial candidates during the campaign period from February 12 to May 11. So using the latent Dirichlet allocation mallet for our topic modeling, we have arrived with 8 topics with a coherence score of 0.36. Emerges the top topic is about drugs, agrarian reform, which with the highest engagement in terms of replies, retweets, and likes. Looking at the top 12 candidates, their most engaged topics or tweets is about peace and order, followed by tweets about their on-ground campaign rallies and education and the youth. This is different, however, with the top 13 to 24. The top most engaged tweets is about drugs and agrarian reform, followed by China, people's right, and finally equality and empowerment. To answer the second question for the sentiment analysis, here's Hurley again.
Thank you. So we did sentiment analysis on both audiences and candidate tweets to see how candidates present themselves and how such is perceived by their audiences. We grouped each candidate by their coalition, Hugpong ng Pagbabago, Otso Diretso, and the remaining coalitions were regarded as others. After getting the results, we have found that most candidate tweets tend to be more positive, but most notably, those that are in the coalition of Hugpong ng Pagbabago tend to show more positive tweets compared to their other coalitions. Also, if we check the subjectivity score, we can see that almost all of their tweets are also subjective. For the audience tweet, we can see that the mean polarity score has lowered, but by observing it or the results, we can still see that it's still leaning towards the positive side. The objectivity or subjectivity score rather still shows us that their tweets tend to be more on the objective side too. For our third question, what are their political stances? This is going to be answered by Raza.
Thank you, Hurley. For the political stance of the candidates, we scrape data from online news outlets to check their stance on controversial platforms. We classified these characteristics into two categories. First one is traditional and the other one is progressive. These two categories describe the stance of the candidates based on Filipino politics and cultural norms. As you can see in the graph, the x-axis represents traditional views and the y-axis represents progressive views. The size of the plotted bubbles represent the number of votes for each candidate and the colors represent the election results. The dashed line on the graph represents the neutrality of the candidates from the two categories. Based from our findings, most of the winning candidates are traditional. So our group has already answered 3 questions that describe the online post of candidates and the audience during the election season. To further help our audience to discern and predict who to vote for the upcoming elections, we created a program that would analyze how similar are the audience Facebook and Twitter posts and the SDG characteristics of the candidates' Wikipedia profiles. To further explain to us our program, I'll give the floor to Rods.
Thank you, Russell. So let me introduce our machine learning model, which we named Makes Sense. It was trained on a dataset that our team have scraped from Facebook, Twitter, and Wikipedia. Currently, the dataset is about 297,000 records of tweets, posts, comments, and content articles. Also with about 671,000 hashtags and about a total of 17 million words. Our model utilized ZSL transformer, which is based on BERT. We made some NLP model tuning so that the model would fit our purpose by this project. The topic labels that we used in training our model were inspired by the Sustainable Development Goals, or SDG, of the United Nations. And the result of training the different classification models is shown on the table that you may see on the right part of your screen. Now, to make sense of how our model works, let's first have a basic example. So we have here the text profiles from 2 presidential votes of 2016 election. Next to it is the set of text from Facebook posts of 2 supporters of each presidential vote. So from that, Mixon's model will process about 14,000 words to compute for SDG scores. And after having the SDG scores computed, the model can also compute for the similarity score between the voters group and the candidates group. The similarity score would mean the likelihood by which each netizen or voter group will vote for based on the similarity of their SDG scores with the candidates. We can derive from the result that Pinky Pinoy group will most likely vote for Presidential Duterte. On the other hand, Rojas Robredo group will most likely vote for Presidential Rojas. Next is, let's make sense of what a bigger, or somewhat a bigger picture. By that, we mean, let's test our make sense model on a bigger data set. In this example, the model utilized a data set of about 5.5 million words. And given those data, our model predicted that the senatorial Angara has the closest SDG similarity score with the voters. In fact, he ranked 6th place in the senatorial race that year. So how does the netizens SDG score similar to the candidate's SDG score? So let's check what topics the netizen is saying about in their social media. Our 2019 election data set consists of 336,000 comments and around 15,000 hashtags. So let's also check what is the SDG score of each senatorial's online profile. Here you go. Yeah, and finally, let's have a quick tour and make predictions about the coming 2022 election. For this example, our current data set is about 365,000 words, about 15,000 comments, and about 3,000 hashtags that talks about the coming election. Also, the netizens' current SDG score is also shown in the graph. That's all for the demo. Back to you, Razo.
Thank you, Rods. For conclusion of our project, we summarize our results to 3 main points. First, the topics of the winning candidates and the losing candidates' tweets are totally different. Second one, the candidates and the audience tweets are tend to be positive and objective. Lastly, based on controversial platforms, the winning candidates are traditional while the losing candidates are progressive. For our call for action, we ask the candidates to know their audience more and to have a voice on important social issues or platforms to help the audience to discern more on who to vote. For the voters, we never stop to remind you to vote wisely and not to spread fake news as it contributes heavily on the public view on the candidates. For our recommendations, we ask data we recommend data scientists to explore more modern NLP techniques and classification analyses, as well as to explore more data sets regarding election fraud and historical data to help our social scientists, researchers, and lawmakers contribute greater knowledge about the matter. Lastly, we recommend them to create data sets on interviews so that we improve candidate profiling for the benefit of the voters. Thank you for listening in our presentation. I hope that you have learned a lot in our project.
Okay, wow, thank you guys. There's a lot of love from the comment section. And I think, yeah, people did notice there was a little bit of a sound issue. We did record this beforehand in case there was an internet issue, so apologize for the sound. So yeah, a lot of things was packed in that presentation. Seemed like you guys did a lot of work. But I think, yeah, to help us understand a bit better in terms of like the motivation behind why you guys did this project, I'd love to bring JC and Felicity now to react to the project. And maybe I can start with one of my questions first. What is the hope that you guys have for this project, right? Like who do you see as an end user for this, and what would you hope that they would get from the analysis that you did here? And anybody can chime in, right? We're doing this live, so hopefully you won't have an audio issue.
So for our project, I think this will benefit more, especially first for the voters to have a data-driven decision, since we do these methods so that we can show that we can decide objectively, and we can also look at the sentiments of the voters, including the candidates online. So one of the major benefactors for this one is first for the voters to make data-driven decisions when they vote, and second for the candidates for them to have a better strategy to look more at more data-driven um, platforms, or let's say demographics, for them to improve their campaign.
Okay, yeah, that's really interesting. I think like there are quite a number of platforms where it democratizes information from so like promises, right? Campaign promises that have been made by candidates. So for the purpose of like holding the candidates accountable in most cases, like after being elected and kind of saying like, hey, you said this at this time, right? So I'm quite curious, like why you guys chose to use Twitter as the source of what the candidates shared, given in those type of platforms where people are being held accountable, it's typically speeches or things that are being said on the record that's being used. Can you guys share a little bit about the decision to get data from that source specifically?
Yeah. So I think we tried to first really explore using the major platforms that the Filipinos is using, which is Facebook and Twitter. But we had some issues looking at some Facebook pages of those previous candidates. Like their pages are not already are not available anymore. Therefore, it's kind of hard to get those information that would contribute to the buildup of our data set. And we saw that the current split of the Facebook post that's currently available as of our scraping of those data sets is more of the audience. So there are more posts of the audience that are related with their hashtags during those elections.
Yeah, I understand the choice of using the social platform, given that the Philippines rank like really high, right, or the highest for the past couple of years in terms of social media usage in the world. Maybe, yeah, Felicity, what do you think about that as a source, given you were formerly a journalist, and also the role of journalists in many situations is to hold the candidates and the politicians accountable to things that they've said by reporting on what they have said, right, in situations where maybe there was nobody recording it. Yeah, what's kind of your reaction to that and to the project?
Yeah, thanks for that, Angela. First of all, I want to congratulate you all. That seemed like a lot of hard work. I personally don't like to spend a lot of time on social media. It is not a very fun space to be sometimes. So the fact that you guys actually went through all of that, I applaud you. Somebody needs to do it, so I'm glad you did. To Angela's point on assumptions about the source. So yes, I was a journalist, but that was ages ago before the rise of social media. But I think more recently, the experience that I could draw from is when I actually did my master's degree, I did something similar to what you guys did about policy narratives and how that affects voters and the way society thinks about social issues. And one thing that I learned from that experience was the source matters, and why we choose the source matters. So I think, and I don't know, maybe for me, I feel that there needs to be some sort of justification as to why social media was used. Yes, the number of people who use Twitter is very large. Twitter, Facebook, etc., is very large in the Philippines. But do we know that how do we know that people make their voting decisions on the basis of what they see on Twitter and not on TV, for example? I don't know the answer to that. So these are some of the things that we need to think about. And I wonder if you, what did you find in your research?
Yeah, aside from actually scraping into the social media, we actually tried to look also, especially on the political stats, because this is very opinionated in terms of it would be spilled out in the social media. So we actually looked out and source our information through various media outlets, news media outlets, to actually get our accurate information of profiling those candidates based on our analysis.
Great. Yeah. So I think triangulation of sources and kind of having a second check is actually a really smart way of making sure you're filtering out the data. And I wonder actually also how much did you apply some sort of filter to weed out trolls? Did the number of trolls actually change the volume of a certain kind of sentiment? I mean, that's another question, right? Is there a mechanism for doing that? I'm not a data scientist, so I don't know if it's even possible.
Yeah, actually, sourcing trolls out of social media posts is another level of machine learning technique or a tool that we can provide. But yeah, for the basis of our analysis itself, we tried to capture everything. So if you actually saw the part where we try to present the sentiment analysis of the audiences, you would actually see, and there is actually half positive and half negative post regarding the election timeline period. So yeah, I think it's a good step in the future in our analysis to actually weed out those specific troll posts that would actually just try to undermine the candidates using their social media power or platform. Yeah.
That's great. Thank you for that. That's not an easy job. So I think my other question kind of relates to what Angela was saying earlier. Sino ba ang gagamit ng data? Who's going to be using this data? Who is your audience? And so, what I found really interesting is you were able to actually identify between the magic 12 and the next 13 to 24, the traditional versus progressive. That's a filter or a lens that I've never seen before, because but I think one of the things we have to think about is who is making, what framework are you using, what social science framework are you using to actually classify something as traditional versus progressive, or is that an intuitive process? So I think that's question number one. I think the other interesting thing that I found that you did was about the connection between SDGs. I love that. I'm all about the SDGs, but again, that goes back to who is using the data. Do voters actually think in terms of SDGs, or are you making that connection for them? It's very interesting to for me what the prediction that I got from your SDG analysis was less about who's going to win or who's more traditional and progressive. As a neutral observer of politics and development, the way I would see that kind of data as a user, as an end user, would be, I'm not involved in politics. I'm not, let's say I'm not voting, but I need to know which SDGs will likely figure into the next 6 years of administration in this government. So I know then what kinds of policies will be. So maybe for me, it's less, because your audience originally was for voters so that they understand who they're voting for, policies, goal-based voting. I'm not sure that when I saw that as a voter, I'm not sure that would have helped me, but it definitely helped me as a development person to see, okay, if these are the people who are going to win, I know that, you know, SDG 876 or whatever it is going to probably be a policy priority. And therefore I could either organize to put my resources towards supporting that, or say, hey, my SDG isn't there. Should I speak more loudly and advocate on behalf of, let's say, SDG 1. So I think in terms of the user, it was a little bit confusing, but I saw more value as a development specialist user.
Yeah, thanks, Felicity. I think that last comment was really, really interesting. Both for the fact that I totally agree with you. I think people who are campaigning on these issues can actually see what's coming down the pipeline in terms of government priorities. But also, I think it also uncovers some of the communication issues around the SDGs, right? Like, how would you communicate? I've seen certain things where, let's say, instead of saying that, you know, this SDG is about climate change, let's actually make it, oh, I want to have clean air as a citizen, right? Like, how does that relate to somebody's lived experience? And then how does that get, how does that get reflected? To the earlier point I think you made about trolls, the really interesting thing is all of these capstone projects are self-directed, right? The fellows like you guys came up with this project because you were curious about the result and you know, wanted to get involved as a citizen. So there was a previous project that actually looked at Twitter trolls, looked at the process. I think, Joseph, you talked about how you would go about actually classifying trolls. And that, yeah, this is an entire different process where you would have to first have a labeled data set of users who are trolls, right? So you can understand like what are the features about that account can actually help you predict. Things like maybe this account was created in the last 3 days. Maybe this account actually only has less than 10 followers and the other followers also have a high probability of being trolls, for instance. So what I see, I think from my vantage point, that's really interesting is that there are bits and pieces that a project that eventually could get connected up to almost be like a giant, a giant data machine. But again, yeah, the question remains like, how can citizens engage with this, right? Because ultimately this is a very potentially politicized topic. What is the right way to engage with this? And what's the danger? In the last part where you talked about, I think the second usage that you saw, like, hey, this could be a tool that politicians can use to understand how they could speak to their voters, right? I think on the surface level, it's very benign. Just as similarly, if I'm a brand, right, and I want to speak to my users and my customers, I want to understand what are they like, right, on Facebook, and how can I market my product to them so they can buy more of my sugary drink, right, for instance. But in this case, if it's about like democracy, like I'm wondering, yeah, with this group, like what do you guys think? Like, I know Data ethics is a topic that we do touch upon in the fellowship, but do you think, let's say today, your tool, somebody who was a candidate saw it and they wanted to use it and leverage for their campaign, like, are you guys for that? What is the kind of code of ethics you think data scientists should have? It's a tough question.
Yeah, it's a tough question since like everyone handled with the technology has the power to yield it, independent of what his or her intention of using it, right? So our wish is to be able to use this platform as a way of democratizing and educating people of what these candidates were talking about, what these candidates are up for, and we hope for that it could be a way or a path to actually make it more inclusive, and at the same time it also protects the voters from being taken advantage. Yeah, I think for now we have to really put into consideration the how we use the data products that we build upon ethically, so we don't compromise the future generations as well.
Yeah, to add to what Sep has mentioned, we make use of the SDGs to like connect it as topics for both the voters and the candidates. In NLP, it's really hard to like produce topics. So for the let's say for the voters, it's actually related to making when it comes to like choosing a leader for the country. Our team believe that our platform will be able to help voters make this election goal-based by like answering the what questions first instead of the who questions. Like most of the surveys nowadays tend to like ask who will you tend to vote this coming election instead of the what goal you want for your country. So our platform will help answer the what do you like, what do you want, what is your goal for your country, and lastly, it can easily answer the who question. And for the leaders, whenever possible, it should be a requirement to know the what questions to ask before either whether or regardless they were supported by these voters during the election.
Rods, I'd like to pick up on that note that you just said. I love it because you're starting to think about what this product would be. It's a prototype. You're starting to experiment with what kind of data is coming out. So that's, I kind of want to toss that back to you, or well, anyone in the team really. Based on what you've learned and the feedback that you're starting to get, how would you refine this into a product? And kind of just one layer of comment that I'd like to add is, you might be doing too much. You might be trying to cater to voters, to the politicians, and to this. And when you're trying to do much, it's kind of like 2-in-1 shampoo. Yes. It's not quite conditioner. It's not quite shampoo. It's not really going to work. Are you shampoo or conditioner? So maybe you could brainstorm a little bit here. What kind of product do you see coming out of the insights that you've generated here? And how would you improve that, putting in mind the usability of the audience that you've chosen?
Yeah, for now, if you'd notice on our current model, it's like in the version 2. So actually, because of the data set that we have, for the candidate side, we only have this profile text from the Wikipedia. It actually related to how we decided what model we're going to use. It's basically based on BERT, and BERT is actually very intelligent when the data source is coming from Wikipedia and books. So to make this potentially a better model for the candidate, maybe we would need additional data from, let's say, their speeches, their interviews, transcript, anything that they want the voters to know from them in text. And for the candidate, maybe um, although we have the data for now, but we haven't really added into our current version, maybe some sentiment analysis on the comment. We count those comments like the haha, the love, the hate, but we really didn't accounted for the current model itself. Yeah, but there's really a lot of potential for this model.
Yes, I definitely agree. I love that idea of some sort of AI bot where an undecided voter might just choose the kinds of issues that they care about. And then on the basis of that survey, kind of not really predict for them, but kind of give them recommendations of who to explore more without telling them who to vote for, right?
Yes.
So those many different things. Thank you for that. That should be exciting. We have an election season coming up. Can you fix that?
Yeah, so I think we have to wrap up. JC was actually not able to ask a question, I think, during this Q&A because he had some internet issues. One thing I think that definitely comes up all the time, right, whenever an NLP project is done for the Philippines is the issue of the fact that it doesn't actually support non-English language in a lot of the libraries that are being used. What I envision, I think what Felicity just shared is kind of a version like The Voice in a potential product where, you know, The Voice, they sing without, it's a blind edition. So in a similar way, you don't turn around your chair and select your candidate until you kind of see what are the issues that they stand up for. So there, we're looking forward to your product, as something that could potentially be pushed out. And there haven't been any actually questions from the audience, but definitely this is a project that's about citizenship and it's something that everybody can relate to, right? So thank you guys again and congratulations for the hard work that you guys produced. So now I want to sort of move on to our second project. I think there's a little bit of issue with the screen. I'll just try to fix that. Yeah, okay. So as we get that fixed, so now we've sort of touched upon, how citizens can inform the direction of government priorities through voting. Now let's take a look at another side of how data can inform decisions within the government itself, right? So policies are how a government affects the lives of its citizens. And so how might we design better policy through data-driven approaches? Right, so the technical answer we already know because this is actually similar to how businesses improve their processes through data. So we can use many of the same algorithms and models that have been tried and tested in industry for policymaking. So up next, we will look at a technically focused presentation on how Davao City can use climate data to predict the outbreak of dengue fever. Let's welcome Escalab's Data Science Fellow, Eric.
Good evening, everyone. My name's Eric Magno, and I'm here to present my capstone presentation entitled Forecasting Dengue Incidents in Davao City Using Climate Data and Time Series Analysis. So if you guys didn't know, dengue is the fastest spreading vector-borne disease in the world. And in 2019, the Philippines actually had its historically most number of cases with 430,000 cases. Although this number decreased in 2020 to 60,000 cases, I believe dengue is still a dangerous disease that needs to constantly be monitored and put into public awareness. Some quick facts. The 5-year average cases of dengue in the Philippines is 185,000, and dengue has no treatment, but the disease can be early managed. So here we have the DOH's National Dengue Prevention and Control Program, and these are the 6 components of that program. As a data scientist, 2 main points of interest I found easily accessible are case surveillance and outbreak response. So the goal of this project is actually the prediction of dengue outbreaks to allow for early response. If we are able to detect spikes in dengue cases early, we are able to respond better to outbreaks. We also create an opportunity for public health authorities to properly adjust to outbreaks in terms of preparation and creating public awareness. Here's the methodology of the project. First is data gathering, where we want to get the dengue cases and climate data. Then we want to clean the data to fit them into a time series index. exploratory data analysis allows for visualizations. We have feature selection, in which climate data and associated lags are determined. Modeling, so we used a Remax and Profit in this project, as well as model evaluation. So these would be the RMSE of predicted and actual cases. So here are my two data sources. First is Pag-asa, which provided me with daily climatic data from 2009 to 2017 for Davao City. These would be rainfall, Tmax, Tmin, Tmean, relative humidity, wind speed and direction, and station pressure. We also have data from the DOH, which provided me with dengue cases in Davao City by morbidity week from 2009 to 2017, and these would be aggregated by district. So if you check out the Streamlit that that's provided, we can actually see a heat map of dengue cases by district in Davao City from 2009 to 2017. You're also able to click each district number to see the population and the name of the district. Next up, we have dengue cases by morbidity week. Here we can actually see the number of cases in each time period from 2009 to 2017. Two things I want to take note of right now are there seems to be a spike in dengue cases around the July to August mark, or the seventh month, and there also seems to be a spike every 2 years. So 2012, 2010, 2012, 2014, 2013 as an outlier, and 2016. So this seems to indicate there is a annual seasonality, as well as a biennial seasonality, or every 2 years as well. Next, we have the seasonal decomposition of dengue cases, in which we can verify there is actually a seasonal component to the dengue cases. Next up, we have the correlation matrix of climate data. Here we can see which features are highly correlated. And for simplicity, we actually narrowed down the features to rainfall mean, P-min, P-mean, RH mean, and wind speed mean. I also use studies on climate data for dengue prediction in order to determine which climate features I wanted to use. So we can see that there's actually a study in which climatic factors, rainfall and maximum temperature, were significantly correlated with monthly dengue cases, as well as another study that indicated that relative humidity and rainfall significantly contributed to the impact on dengue transmissions, as well as relative humidity highly correlating with a 2-month time lag. So it shows that time lags can also be used. Next up, let's discuss the two models that I decided to use. So first off is Arimax, in which we can say that climate data can be used as exogenous variables, as well as Prophet. We can also actually use climate data as regressors, but we did not use it for this project due to time constraints. Next up, which parameters we have to tune for both models. So for our Emacs, we have the P, D, and Q parameters, which are the autoregressive of P, D for differential, and Q being the moving average parameter. For Prophet, we actually tune the seasonality as well as the trend or growth, as well as holidays, which isn't really relevant to this project. We also see whether or not we can require the data to be stationary. For Emacs, this is actually a requirement, while for Prophet, it's not necessary. Uh, Briefly talking about stationarity, what it means is that for each period of the time series, the mean, standard deviation, and variance should be constant. So one of the ways we can test this is the augmented Dickey-Fuller test. So these are the confidence intervals for my particular time series, as well as the score that I got. As you can see, it's lower than the 1% up to 10% confidence intervals, as well as the p-value is shown, which shows how relevant this score is, or how confident we can be with the test. So we can assume that the series is likely stationary. Next up, we have how we tune the ARIMA model. So I actually used a grid search approach for comprehensiveness, and we can see the ranges for which I tuned the P, D, and Q parameters, 0 to 3, 0 to 1, and 0 to 3. And here we can see the best model, or the best parameters for the ARIMA models, as well as the RMSE score that I got using walk-forward validation. And we can see each prediction interval I used, 1 week, 4 weeks, and 12 weeks ahead. Next, we can see the feature importance of climate data I used. So I actually tested them out with the best model per prediction interval with a lag of 0 to 12. I also used a grid search approach similar to the last slide. So we can actually see that the RMEC scores with each correlated climate data feature, and T-mean seems to be the most relevant across all prediction intervals. Next up, we have the Aremax model tuning. So actually, the X in Aremax stands for the exogenous variables part. So this would be including the climate data features as opposed to a standard AREMA model. Here we can see a dictionary of all the climate data features I use. So these would be the top 2 lags per climate data feature for each prediction interval. Here we can see the dictionary of the most relevant climate features and the best score that we were able to get. So none would indicate that the feature was not used, and here 0 would indicate that a lag of 0 was used. Next up, we have the profit model tuning. So here I actually used an intuitive approach. So I assumed a logistic growth for this model since there seemed to be a natural floor and cap for the number of cases. Here I used a floor of 10 and a cap of 500 as well. I used multiplicative seasonality because using additive seasonality, we were actually getting a result of negative cases for sometimes time periods. I also use a biennial seasonality with these parameters for your order 5 to 25 and prior scale 10 to 25, in which I used documentation for the default parameters as well as standard approaches to tuning these parameters. Biennial seasonality indicates an outbreak every 2 years. And the annual seasonality was also added with these Fourier order parameters. This part is indicated by the outbreak around July to August, which is the rainy season in Davao City. Same thing, we also have the RMSE scores for each. So finally, we can compare the results for AREMA, AREMAX, and Profit across each prediction interval. We can actually see that AREMAX performed the best for 1 and 12 weeks ahead, as we can see here, while Profit performed the best for 4 weeks ahead. One thing to note is, however, so these are the graphs that I was able to get. So red being the predicted values, while blue being the actual cases of dengue. So if we actually look closer, we can see that Arimax is actually able to predict values closer and finer compared to Prophet, while there seems to be a small delay 1 week ahead for predicting the outbreak. And if we look at the 12 weeks ahead, Arimax is actually not really able to predict this outbreak in time, while Prophet is actually able to pretty accurately predict when this outbreak will occur. So if we look at the conclusion, Arimax seems to be a more accurate time series model in terms of RMSE as a metric 1 and 12 weeks ahead. Despite this, Prophet predicts more accurately 4 weeks ahead. Prophet is also able to more accurately predict when a large outbreak will occur for longer casting intervals. Prophet is so the most relevant conclusion is that Prophet is able to successfully predict the when of dengue outbreaks in Davao City. Some recommendations I have is that we should explore more meta models for dengue incidence prediction. So if you look at studies, LSTM, which is a recurrent neural network, seems to be the most used model. We could explore using climate data as regressors for Facebook Prophet, explore using more current data for both dengue cases and climate. So some more applicable recommendations we have are that we can create models that are able to successfully capture the scale of outbreaks. So if you look at the last slide, we want to be able to overestimate the number of cases so that we can predict the scale of the outbreak other than the when. And we can create a pipeline using running morbidity week cases and weather forecasts. So a bonus slide is comparing neural networks actually to the same use case. So we can see that stochastic gradient descent with backpropagation neural network, backpropagation with genetic algorithm neural network, and generalized regressive neural networks. We can see that neural networks actually dominate this dengue incidence prediction use case. And we can maybe infer that maybe neural networks work better for dengue incidence prediction. So that's the end of my presentation. Thank you. And if there are any questions, feel free to ask.
Wow, thanks so much, Eric. And as somebody I think who did this project by himself versus a group project, congratulations. So yeah, I think it was also super educational. Like you walk through the technical details of the models, I think in a way that was, yeah, was also very informative. Would love to find out first why you decided to do this project. Also, I think there's certain topic-specific knowledge that I think you might have had to learn, if right, like in terms of like how does dengue fever actually spread, to get a sense of like, hey, are the features that I'm looking at make sense? But yeah, can you first share with us like why you were inspired to do this project?
Thanks for that question, Angela. So, a brief background on why I actually did this project. I actually conducted a use case similar to this, but with neural networks during my undergrad thesis with my shout out to my thesis partner Nanen. Um, so yeah, we were actually comparing like the same use case, so dengue incidence prediction, but with the models I used in the bonus slide. And during my journey in the bootcamp, I actually wanted to apply the skills that I learned and discovered mostly on classical time series analysis um, techniques as taught by JC. Yeah, that's kind of um, my that's how I was influenced into performing this project once again.
Okay,
And yeah,
yeah.
with your second question, when it came to what kind of knowledge I had to learn, so there are a lot of studies done with the same vein. So dengue incidence prediction with climate data as a variable, as an exogenous variable, and they would compare, like for example, how the dengue population would only breed at certain temperatures and certain rainfall, certain humidity, and those would be factors they would consider. I didn't really go into it in this project since because of the timeline. And yeah, those are the kinds of things I had to look up on.
Yeah, thanks for sharing that. I think it's quite interesting because like ARIMA and profit are used in industry, right? So stuff like ARIMA is used for stock price prediction, for instance. That reapplying it to something like this sort of more like data for good use case is hopefully, yeah, inspirational for more people to look at tools that they have at their disposal and say, how can they be applied to more of a public good example? So JC is finally back after his internet hiccup. So as the person that taught Eric about these time series models, yeah, would love to hear from you, JC.
Hi everyone. I hope you could hear me clearly now. I had to have another device connect to this call to fix my audio problem, but hey, I'm here. So hi Eric. Thanks for your presentation. Also, it has really shaped up from when I first met you in the call planning for this or your presentation up to now. So good job, no. So yeah, for the interest of our eager learners, no, our viewers who would probably be interested in learning the time series. So could you just briefly recap and explain to us what exogenous and regressor variables are?
Yeah, so they're actually pretty similar. I would say they're exactly the same. So what they are is basically, so the dengue cases are the endogenous variables or the dependent variable. That's the number of cases per week that I used, and the exogenous variables are more of the influencer variables. They're the ones that influence the cases. So those are the
Correct.
climate data that I used.
And then you mentioned something about lags. No? So what are lags and how were you able to apply that in this modeling exercise?
Yeah, good question. So
It is 6
actually,
o'clock p.m.
the climate data that I had to fit it from daily into weekly data. And from there, you could see that if you looked at my Streamlit, you could see that the data matched up exactly with the case data. So I would have weekly data from 2009 to 2017. And when using dengue cases as an endogenous variable, you can actually shift your climate data by a certain number of weeks as a simulation of whether 0 up to 12 weeks back influence the climate data. I mean case data variable more than actually the 0 week lag, which is the exact match up to the case data.
Well said, Eric. No? And then we saw in your results that it's the more recent data. Actually, if I'm correct, it was like the lesser lags, like 1 to 2 weeks, and actually no lag at all. That influences the local dengue cases in Davao. No? So good job. No, so I guess this one's also an interest for our viewers. No, so we know that getting data, like public data, like say climate data and dengue data, any kind of disease data here in our country is very difficult. So could you just take us through your process of getting this data? Because I know some of people here are interested in hearing that.
Yeah, actually, that was one of the more troublesome parts of the project, even though I did it years back during my undergrad. So we request the data like months back, maybe a 2 to 3 month time period before we actually got the data. So we actually got it through the FOI's website, and then we waited for a response from them. And then we actually had to follow up from the individual departments to actually get the data locally, because during that time they were only able to provide the data through flash drives, and that was around the 2017 time period. So yeah, that was how we approached getting the data, which is one of the more troublesome parts. But yeah.
You had a lot of head time with getting the data, no? So it's just ripe enough for you to use it in this boot camp. So yeah, I've got a couple more questions, but maybe Felicity would like uh, uh, to give her questions first.
Sure, thanks, JC. Eric, bumigat ang aking salamin. It's so like, I'm so not a data scientist, but I really appreciated how you were able to visualize it for people like me who are users of these kinds of data. I wanted to remark first on your comment on ang hirap kumuha ng data from our government. I just wanted to let you know that actually, with the help of Esquelabs as well, we have just launched Data for Empowerment Alliance. It's on wesolve.ph /data for empowerment. And this is really a study about how the data science ecosystem in the Philippines has a lot of barriers as well as opportunities. In partnership with FOI, who recently announced that there is now an open no wrong door policy, which means pag pumasok kayo sa FOI and you need help, they're not going to say, I don't have it. They are going to be the ones to help you find the right agency to do it. And so together with Esquelabs and at least a dozen other organizations, including government, civil society, and private sector, we're trying to build a new community of data scientists who will open up and make data not just more accessible, but more readable and usable. So folks like you can actually do the work that you're good at, and not have to deal with all of those problems first. Great. So comments and questions. I really appreciated this. I could see a lot of value with dengue. Pwede rin siya, I mean, pwede ba natin itong gawin for COVID? And many other issues. And so I think that there's a lot of replicability that's possible here. I guess my question to you is, how do you imagine you could take this project to the next level? Who do you think could use this, and what value do you think the science and the predictive analytics that you've brought to the table can do for this? I guess that's question one. And sorry to add on a question two, but we are also entering a world where there is regression to the fat tail instead of regression to the mean. We're starting to see a lot more of unpredictability in climate, in everything. So how do you intend to use this volatile environment and make sure that there is integrity in what is currently very valuable data? So it's a 2-point question. Who do you think could use it? How could you improve it? And how would you factor in the volatile environment that we're in?
Yeah, thank you for those questions, Felicity. When it comes to the first question, I think I briefly glossed over the last point I had in my presentation, but an ideal use case for me would be using a similar model with more recent data, of course, because I only had up to 2017. And using, for example, DOH would be able to constantly feed the number of dengue cases every week, every morbidity week, and constantly update that, as well as possibly using weather forecasts as a feature. I'm not sure how that would work, but that's something that we that could possibly be explored through the models. When it comes to the second question, dealing with the volatility of data, um, I think that's something that would be valued if we created models that where you could constantly feed data and constantly learn as we go. And that's one of the advantages that comes with neural networks actually. And that's one of the reasons probably that those are the models that are used for um, dengue incidence prediction in other studies.
Great. Yeah. So Eric, I wanted to just respond to your first response. I love how you're thinking about how how you could actually modify the model for use of DOH so they could continue to input. But then as data scientists and as people who actually inform the way we develop social solutions, we need to start thinking also about how that data is eventually used, diba? And so one of the things that came to my mind as you were developing that, and maybe something that you could think about in how you're designing the dashboard for this or the usability of the data, is what about the LGUs and the public health administrators at the community level? The way, if I were one of them, the way I would use that data, just to kind of throw something at you there, is it will allow me to prepare a certain period of the month or when during the year I should be doubling my staff, doubling the orders for medication and facilities for the surge for the surge. So how do you actually use the heat map, not just to look back in time as to how much dengue has happened, but to create a heat map that tells us of the future. So as a health administrator, I know when I should be expecting dengue cases. And that, to your point, it's early manageable, diba? If you get it ahead of time, if you treat it early enough, it is ultimately survivable. It's very survivable. So how can we use that data to make sure that there is early detection? So how can we use the heat map to do that instead? So just wanted to share that in case.
Yeah. Thanks for asking that question. I guess I'll share really quickly. Um, so one of my slides, I actually shared a demo of one of the exploratory data analysis I did in my Streamlit. I think the link's shared. So if we actually use this kind of heat map, we can actually determine which districts in Davao City um, are the hot zones for dengue. So actually, LGUs could assign staff to particular districts during those hot periods of times for dengue during the outbreak seasons. Yeah, that's a very good observation. Then that's
Yeah.
how we
So
could use
how do
the.
we extend that scroll to 2030 or something like? Do you know
Yeah,
what I
that's like
mean?
yeah. So actually, it's kind of hard to go past as we could see with the results I had, as you increase in the forecasting interval or how far you predict ahead, the accuracy severely impacted. Especially since I only have up to 2017 data. 2019 was the major outbreak for dengue in the Philippines as a whole. So how that would affect the models is yet to be seen. Um, but I guess we could see with the profit models, we could kind of accurately predict when this would occur. So that's around every 2 years. So as well as being in the July August months, which is the rainy season in Davao City.
Yeah, thank you, Eric. For sure, I think that makes sense. Like what Felicity suggested, that's pretty much getting into like prescriptive analytics to be able to derive the prediction and directly link it up to some sort of decision-making process and trigger like real life implications, right? Just like how a company might use a similar model to predict like when are people going to purchase our product, and so we can like stock up on the inventory of this. Maybe I can throw it back to JC for our final question as somebody who advised this project.
Yeah, So I guess this project also unites some two government offices that don't really talk much. Like we have climate data from Pagasa, and then the Dengue data from the LGU. So what I could imagine for this project is if this was adopted, no, these two institutions would have to talk to each other to build the system that would take in Eric's tune model. No, and that I agree with Felicity and Angela that the output of this model would definitely be used to pre-position people and pre-position maybe medicines, and even actually before we could actually use the output of the model to call the outbreak in the first place. So
Yes,
if
where do you
we
need to
predict,
send the resources ahead of time, right? So that you actually don't hit those heat maps.
we can even go ahead and identify places where we could do cleanup drives, because we know that dengue is from mosquitoes, right? So we could remove those larvae from those I don't know, stagnant water that lies everywhere. Some more preventive measures that come before the actual epidemic. So there's that. There's also the much like typhoon, and not really typhoons because you can't prepare for that and can't really weaken typhoons, but we can definitely weaken such I don't know, events, something disease related like this. So yeah, that's what I want to say.
Yeah, if I may just comment on top of what JC was saying, I think that's something that we need to think about when we collect data and like how it's going to be used. No, at the end of the day, policy is an exercise in resource allocation and prioritization. So to JC's point, if you know where the outbreak is going to happen and you only have X number of pesos to deal with it this year, where would you bring it to? So that's one area. And I would say that while typhoons are not predictable because it could pass through any part of the belt, you could probably take a look at what cities and villages tend to take longer to recover, what kinds, because of why, and start to make correlations. Is it because they're farther from a main road, there's not enough infrastructure, so it's muddier, therefore, so it's things like that. So it doesn't have to be where the disease or the typhoon is coming from, but already the impacts of that. Where are the impacts hardest, even if we don't know when the typhoon is coming or where, and that can help government also allocate resources and make decision making about budgets.
Awesome. So sounds like, Eric, you're going to get recruited, right, into government and implement these things that we just talked about. All right, yeah, I think we didn't have any questions come through from the audience, but I think, yeah, that's quite okay. We had a pretty lively discussion here. So thank you again, Eric, and yeah, congrats on your project. So we've already met Felicity here, but we actually invited Felicity to also give a presentation about Resolve and share with us a bit more about the Data for Empowerment Alliance that she just mentioned. Felicity's bio is on the screen again. Could I ask Felicity for you to come back with your camera on? Yeah. So I guess I wanted to chat with you a bit before you show the presentation, right? Because I think before you saw these projects, I think one of the questions that you had was, hey, what's my response to these projects as somebody who maybe is not from the technical side of data science? But now that you've seen like 2 examples of what could be done, what are some ideas that are bubbling up, or what are some of the ways that you see, given the vantage point that you're coming from, what are some ways for fellows to continue to do their projects, or how can this get absorbed up by other initiatives that are happening already?
Yeah, so I think the first thing that really came to my head is it really reinforced 2 things for me. One is just how much talent we already have in this country. There's a tendency to think that the Philippines can't take care of itself that we need to rely on foreign donors and foreign experts to help us with our problems. But it's very clear that we have the talent here and it just needs to be developed. It just needs to be kind of elevated. So I think that was the first thing that it reinforced to me. And it's actually something that we all really believe in, that there is so much energy, talent, passion, and ability in the youth of the Philippines. And what we need to do is really bring them together and harness that talent to do good, to make actual change. So that's the first piece. I think the second piece that this reinforced for me is just how much we really need to work together. We tend to work in silos. I was just thinking about the first group and voters. Data scientists work on their own, think about the data and all of that. And then you have your political campaigners who are thinking about their own things. And then you have the advocates who are thinking about their own things and doing whatever it is. And nobody is truly effective at what they're doing unless they come together and share not just information, but share the way we think. Because we need to approach the same problem with very different lenses. And when you're only looking at it from one lens, you're only going to come up with a solution from one lens, right? And so being able to have these very constant conversations, being able to think about the problem that you want to do, the problem you want to solve from the lens of so many other people, and then apply each of your individual skills towards that, we could do so much. So those were the first two things that really popped out in my head. And wow, I feel like we should be calling you guys. We have so much data needs.
I find that last one super interesting. So we are also partnered with a platform called Umdena that works with international organizations to produce data for good projects with like international teams of AI professionals. And one of the things that, I've spoken to them about is this idea of like apprentice with a problem for data scientists, right? It's the case for anybody who has a type of skill that once you have a hammer, everything is a nail, right? Once you are a data scientist in this case, everywhere you look, you said, oh, we can just solve that with data. In reality, a lot of cases, even after the recommendation is made or the predictions are made, there's a lot of different roadblocks as to why either that's not sufficient, or it's just simply not the right solution for a problem.
Absolutely, yeah, and just kind of to your point on data, like when you see data, you think everything can be solved by data. I would actually argue that that's partially true. We could actually solve a lot of things with data. It's just that we need to start looking at data as not just the quantitative piece, but what does that data represent? What is the story behind that data? Because at the end of the day, when you keep data in kind of a petri dish, it's in a lab. How does that actually, how can you actually use that in the real world? And I think that's the challenge that many of us face right now. Both of us, both on our side on the field, who are trying, like we're using our intuition, what we know from experience, and maybe some desk research about what the problem is. And then you have the data scientists who could see where the problem is, but why are looking at the dengue issue, why is it specifically those regions that have higher dengue incidence? Why is that? We know the fact, but we don't know the why. We usually know the why, but we don't know the what. So if we bring our powers together, we could just come up with so many solutions.
Yeah, that's super interesting. In a separate project that was previously done by a group, they looked at multidimensional poverty and what are the non-income indicators that are indicative of poverty, for the similar reason that you shared of like helping the barangay actually allocate their resources when it comes to aid. And so in that example, exactly kind of what you're saying, they found that one of the top predictors of multidimensional poverty was the access to clean water, which was surprising, right? But at the same time, yeah, we couldn't really, without having the context, know why that is, without having the field research or without actually talking to experts that has worked on this issue. So that's a perfect example of an insight that was uncovered after a lot of data was looked at. And it was missing, I think, a certain piece of that. So I guess from here, yeah, do you want to share a presentation about WeSolve and tell us a bit more about what you guys are working on?
Yeah, sure. I mean, before we jump into that, I kind of, there's something that I have been thinking about in terms of data science. And I think when social impact people, for the social impact people in the room or for the data scientists here who want to work in social impact, there is a myth that data comes in at the end of a project, that it is used for measurement to look at the past. Did we do well? Did we not do well? And maybe use it for evaluation moving forward. And this is really important, but it's not enough. What we need to be doing is putting data at the very beginning of the impact cycle. A lot of the time we come up with solutions with not enough data. We think we know the full picture and therefore propose the solution. But sometimes this is where data science really comes in to help complete that picture, to help turn it into HD, basically. And so what I love about what Esquel Labs is doing, and I'm being very greedy, is making more of you little nerds. I love it. Because we need more of that. We need more people like you who can see this and help us look at what is really the source, the root cause of a problem. Because with enough data, both qualitative and quantitative, talking to each other, you would be surprised at how different a solution might come up with, because the whole issue about social impact isn't about solutions. Social impact is not about solutions. Social impact is about framing the right problem. And without data science, we cannot frame the right problem. Maybe we'll touch a piece of it, but the most successful programs are those that are based on solid data, that are then accelerated by solid field work. So I would love to encourage all of you, for those of you who really do care about the Philippines, and I know most of you do, there is a place for you. There is a growing community that welcomes you, that welcomes your talent, and would love to work with you. Keep reaching out. We have lots of projects, which I guess I could talk about now. Do you mind just giving me a second, because I lost my little presentation?
Yeah, no worries. Take your time.
Okay.
Yeah, I mean, just this is definitely a very willing audience. Yeah, I think 80% of the capstone projects that are done for Data for Good, and this is at the own volition of the fellows. So, nobody is telling them to look at these projects, but for their own experience, right? And
right.
In a sense, I think now we do have some graduates that are working in government. So for instance, like the COVID dashboard that you see being produced by DOH, we have grads that are working on that within like those teams. And hopefully, although this is, and maybe something that's good that came out of a bad situation is maybe after COVID, citizens would demand more data from the government, right? More transparency, things like dashboards, and that demand would, hopefully trigger some sort of wave of these skills being embedded in government.
Absolutely. And again, I guess to that point, so what we have done is we've launched the Data for Empowerment Alliance, as I had mentioned earlier. This is a platform for people who are collecting, producing, analyzing, harmonizing, and using data to come together to speak to each other about how data is used. And I think that was, we always say what gets measured gets managed. I don't think that's enough. It's what are we measuring? Why are we measuring it? So yeah, it's those are the things that we want to kind of elevate when it comes to data science. And so we're working with governments, we're working with civil society who are using these data, and what we find is everyone has the same problem. No one's just talking about the problem, and when we're talking about the same problems together, we can actually come up with a solution. So I do have a little presentation just to kind of show you guys why I talk a lot about collaboration, if that's okay. Can I share my screen? Great. Do you see that? Do you see my little wheel
Yes, we do. Go ahead.
Okay, great, perfect, great. So what we solve is we're actually a coalition incubator. We are a coalition incubator and a collaboration accelerator. We help people come together to do social change. We're also a platform for change shapers. So people like you who want to do something about the issues in this country can come to us and use our system of practice to accelerate whatever it is you want to do using the combined power of the social system. And the final piece is we are a youth leadership bootcamp. So just like you, everybody is under the age of 30. I hope most of you are under the age of 30. And this, our belief here is that it is the young generation, the younger people who really have the right to shape what the future is going to look like, because you're inheriting the future today. So our theory of change and systems change is, we could talk about structures, we could talk about systems, we could talk about government and institutions being what's wrong with the system. But at the end of the day, sino ba ang nagpapaandar ng sistema? Hindi ba tayo din? It's the people who are making the system work. And so our theory of change is, how do we change the relationship of the people in that system? And so this kind of goes back to data scientists and social impact people coming together to co-create solutions for our shared challenges. Yeah, I think that's I don't know how much time, but this is really just one thing I want to show, is what we solve does is we specialize in backbone organizations. So the people who bring collective action together. Collective action has 5 conditions. It's common agenda, shared measurement, mutually reinforcing activities, and continuous communication. Very obviously, shared measurement is where data science comes into play. But like I mentioned earlier, it actually comes in much earlier, even before creating a common agenda. It's in what we have as a discover phase, where we really try to understand the nature of the problem. Through qualitative and quantitative data, we are actually able to frame the problem. And then when we have a common understanding of a problem, you will find that yung mga nag-aaway-aaway dyan about what we need to do about a problem they're seeing from many different lenses, once they have a common understanding of that, it is so much easier to shape a common agenda of what we are trying to tackle. And then from there, we have a system of practice that allows us to mobilize together. And very importantly, throughout this process, we are measuring how we're changing. And I think that's, I'm going to stop this presentation now because I don't want to bore you too much. And I think that's my final point here is based from what I saw earlier in the voter, the voter data project, is there was an ambition to change voters, the way voters choose their candidates. But the question then, my challenge to you data scientists, is how, not just the what are they voting for, but how are they voting? Because it's in how that we actually come up with a solution. And that's what we're here to do. We work in hunger, we work in urban mobility, we work in data science, very obviously. We're exploring a number of different areas as well, including education, civil society, and youth in BARM. So we have many different areas that need data scientists. Check out our website, reach out to Angela or myself if you want to get involved. We have so many projects. So please just, if you're interested in learning more, we're happy to talk to you. So thanks so much for having me. And really impressed by what I've seen today.
Wow, thanks so much, Felicity. I love how you threw a question back, I think, at like us, as compared to, I think, normally we ask the speaker questions. Okay, so let's see if there are any questions from the audience. One that I love to find out from you is actually more about how does this like multi-stakeholder cross-sector collaboration actually work? I know that you were at Rockefeller for the Rockefeller Foundation for a number of years, and they're really well known, right, for their collaborative approach that includes government, other foundations, civil society. What are the areas that you see now in the Philippines where like that approach could be used?
Well, you know, the interesting thing about the Philippines is we're actually known for collaboration. We are a country of coalitions upon coalitions upon coalitions. I think where the challenge that we're seeing, the challenge that we're seeing is these coalitions don't necessarily last, or impact tends to be quite limited. And that is where the backbone comes into play, because someone needs to continue to push that. So how do these collaborations work? How do we make them, how do we sustain them is, I think, what your question is. And I think this is where data really comes into play. When we continue to do things, we start by doing it together with a lot of energy. But when we're not measuring it, when we feel like we're doing a lot, but things aren't changing, this is when we really need to look back at, well, are we actually trying to solve the right problem or the right subset of the problem? Because our tendency is to try to solve the whole issue. And yes, we need to do that because it is systemic, but we also need to know how to splice and dice the system and see where the interconnections are across that. Data comes into play by helping us understand, for example, Angela, the example you gave earlier about, ultimately it was about water. And if you don't pull in water, you don't pull in the water people, you can't solve the agriculture issue. We're actually seeing a lot of this in some place that you might not even think of. We're seeing this in birth registration. People think the birth registration issue, depending on where you sit, is either an issue with the hospitals, an issue with the LGUs, an issue with people not being literate, an issue with road access. And so the solutions just kind of stick to that area. With the kind of research that we were able to do, and we are now engaging data scientists as well to start looking at this and start evaluating how we're approaching it. We're actually combining all of those. It's everybody, but then you have to take it piece by piece, and there has to be someone at the center who is communicating with all of that to ensure that people are collaborating and sharing information. So I don't know if that's a clear answer to this, because it's very messy. If we assume that there's a linear answer to everything, then we're not doing something right. It's very messy, but someone's got to do it. Someone's got to deal with it. And I think where data science comes in is you help us make sense of the mess so that we know exactly how to solve these problems.
Yeah, I think it's absolutely right that it's very easy to get initial momentum, right? Getting a meeting is easy, but turning that meeting into action, or committed action over time, like that's the hard part of partnership, or rather like the art of partnership. I guess another question for you, and this is something we discussed before, is how might we actually use a data-driven approach to decide what are the issues of priority for even like your organization, or even, let's say, for fellows who want to continue to work on these data for good projects, other than their lived experience of, I care about this subject as somebody who, is a citizen, is going to vote. How would you recommend anybody in this sector go about picking and choosing what are the issues that they should care about? Ultimately, I think it's a combination of a data-driven approach and personal passion, right? Because if you don't have the latter, then you're just a robot. But how do you guys do it at Resolve, for instance? Like, so many different projects you can work on. How do you go and choose that?
That's a very interesting question, Angela, and I don't have a clear answer to that, because I think that's something we ourselves are also starting to figure out, but I can share how we're starting to figure that out. I think it starts with intuition. It starts with observation. When you see something, you start to think about, well, where is this coming from? And I think applying a scientific mind, an inquisitive mind to what the issue is. So if, for example, you see a problem with, hunger, depending on where you're at, you are looking, if you're, for example, in the city or in a school, you're only thinking about feeding. And so then you put all your solutions towards feeding. If you're a farmer, you think that the problem with hunger is we're not producing enough, or there's so much food that's going to waste. And so how do you connect all these dots? The way we choose problems is, first, we start to think about, does this align with our mission about collaboration? Is this an engineering problem where it's very complicated, but you could build a rocket ship. That's, complicated, but there's a linear path. For us, we start to think about, where are the issues where so many people are working, but it's not moving anywhere because we're not coming together. So for us, that's our mission. Therefore, we look at it through that lens. From a data science lens, if you were coming into our group, or the way, not necessarily our group, but the collective impact mindset, I would really lean on your curiosity, your scientific rigor and analytic minds, because for those who don't really have that, you kind of just go with gut, and then you just kind of keep pushing at one solution. You guys are so blessed that you actually think about you actually think about the process of this. So kind of like going backwards, in our birth registration issue, it started with the observation that people weren't getting their ayuda. So we would the initial assumption was, is there a distribution channel problem? But the more we dug into it deeper and deeper, layer by layer, that backwards that backwards process of curiosity, we then start to see it's not just a distribution issue. It's actually people aren't even registered. Now, why aren't people registered? And there are four different reasons that we found. And under each of those reasons, there were sub-reasons. So it's kind of like asking the why. And so data scientists can actually partner with social impact specialists about how to ask those in a very rigorous way to find the root of the problem, and then design, going backwards from down here back up, design a way to figure out how to solve that. So I see so much potential between the social impact specialists and data scientists. I think we could do so much together.
Yeah, that's so cool. I love how you share that social impact is not about solutions. It's the first time I've heard that said by somebody. I think the comparison of that on the data side is that data science is not about machine learning or it's not about like cool algorithms. Data science is also about asking the right questions. So that's the exact same thing that you shared about social impact, is about asking the right questions. So that's super cool. I feel like I've kind of like put those two things together just at this session. And yeah, it definitely seems like we can have a much longer conversation about this topic, which I think that's exactly what we're going to plan to do in the future. And so, yeah, maybe this is a great way now to just segue to the end of the event and to share with you guys that you can learn more about the past capstones, some of which we mentioned at this link here, which will also be shared in the chat. And just as Felicity kind of shared, there's just so much opportunity to use data in government or in social impact. So yeah, we would like to share with everybody that if you're interested to become a future data science fellow, we offer scholarships like the Data for Good Scholarship for fellows who want to pursue a career in government or NGO. And if we go to the next slide, please, there you can see a bit more information about that. And the next cohort will start on May 10th. Okay, so finally, we'd love for you to take your time to vote for your favorite project from today with a link that's going to be shared both on the screen and in the chat. And as we say goodbye, I want to say a special thank you again to Felicity from WeSolve for sharing her expertise with us, as well as JC, our data science instructor. And let's just have a big round of applause for our fellows for the curiosity that they shared and the commitment to ask the right questions. I'd like to close this off actually with a concept that I read recently from a book called Data Feminism by two professors. Collecting large amounts of data is costly and resource intensive. Only government states, corporations, and some elite institutions have those resources. So data collection efforts tend to be driven by their values and priorities. And quantification is representation. But the inverse is also true. So if data is not collected on a particular group or on a particular issue, then institution and power can pretend that the issue doesn't exist. So I hope this session leaves you engaged and excited about the different possibilities for citizens, civil organizations, and data scientists to come together for more of these projects. Thank you very much, and we'll see you tomorrow.